Welcome to Part 7 of Competency 17. In this video, we will find the percent under the normal curve given mean, standard deviation, and data boundaries. Number 1. Given a normal distribution with a mean of 15 and a standard deviation of 4, what is the percent of the data that lies between the values 11 and 15? Okay, the first thing I'm going to say is that the way the question is written, we can use the numbers as is, okay? So let's go to our calculator and then we're going to discuss how to put the information in, okay? So what you need to do is push second vars, and we're talking about number 2. This is a normal CDF, okay? So let's go to 2. Okay, now in your calculator, you may or may not have this -1e to the 99. That is such a large number that it's going to include everything. So you have to know that this is what you want if you have no lower bound. But we do have a lower bound. So what do we have here? Our lower bound is equal to 11. Our upper is equal to the 15. I can write that 11 a little better. Okay, now we know that our mean is also 15, which is just a coincidence how it's written. And then the standard deviation is 4. So that's what we want to use. We want to use 11, enter. Our upper is 15, enter. Our mean, or mu, is also 15, and then our standard deviation is 4. Push enter twice, okay, and again. Now, of course, that isn't a percentage, so now we need times 100 to see it exactly how it is on our answer. And when we round, of course, option C is acceptable, and that is correct. Okay, now let's keep going to number 2. As we move along, the conditions will change a little, and as they change, I'll explain it to you, okay? Given a normal distribution, okay, and that's basically code, hey, you can use what you have in your calculator. It's not a different type of distribution, all right? Okay, given this normal distribution with a mean, there's our mean of 60, and here's our standard deviation of 5. What percent of the data is between the values 65 and 75? Okay, again, we can use the numbers as is. Okay, 65 is the lower and 75 is the upper. Okay, the reason we can use them as is, and I said that before and I'm saying it again, is because we aren't given more information or specific details of information in our question. So let's do the same thing we did before. All right, so second vars, number 2. Okay, our lower is 65, enter that in. 75 is our upper, enter in. Our mean is 60, we'll enter the 60. Now, standard deviation is 5, so 5, enter. Remember, we have to push this enter a couple of times. Now, to get an actual percentage, it's times 100, push enter, and now we can round, and option B is the correct percentage. Okay? All right, let's keep going. Now, for this one, our conditions, they do change slightly. Okay, so we just make our adjustment, answer the question. Okay, suppose that 1,000 data items are normally distributed with a mean of 100 and a standard deviation of 12. How many data points lie between the values of 88 and 124? Okay. We use the same process we did before. We can use the numbers as is. go through the process. Then at the end, we deal with the 1,000. All right, so let me show you how we can handle this. The simplest. I mean, there's more than one way to do this, but let's do the simplest with our calculator, okay? So again, we push second bars. We want number 2, okay? And you can see that we're in between 88 and 124. So again, our lower is 88. Push enter, upper of 124, enter. They give us a mean here of 100, okay? And then standard deviation of the 12. Now push enter, enter. Okay, enter again. This gives us a value, but it doesn't just say what is the percent. It says really they want to know what percent out of this 1,000, out of the 1,000. So you multiply times that 1,000. So times 1, 1, 2, 3, the 1,000, press enter, and we actually get a number value. We're not looking for the percent. We're looking at how many of those items are within this space. Okay. So that's how you handle this particular type of question, right? So D is our rounded option. Okay. All right. Let's move on. A certain company makes cell phones. The mean life of the cell phones is 38 months with a standard deviation of 4 months. What percent of the company's cell phones will last longer than 35 months? Okay, now we have a specific scenario. It is about cell phones, and cell phones are discrete. However, we can use the numbers as is because of this wording, longer than 35 months. So the way the calculator is programmed, when we put in that number, it will give us everything above. It will not include the 35. So it is acceptable for us to use the number 35, okay? And this applies when we have the discrete situation, okay? And I'll explain that with further questions, okay? So this means we have a mean of 38, right? We have the standard deviation of 4. We have a lower of 35. But what do we put in for the upper? That is when we put 1e to the 99, okay? The calculator needs this large number in order to function correctly. So that's what we enter. Okay, so let's do that. Second, vars, we need number 2 again. All right, but our low will be the 35. Now enter that. Now, how do you get in the 1E99? Well, that's not a big deal. Push 1. Second division, see the E above it? Push that. 9. And there you go. Enter. And we have a mean of 38. Enter. Deviation of 4. Enter that twice. Okay. And again. All right. And then we want a percentage. So we push times 100. Push enter. That gives us a rounded option of A. All right. Okay, good. Let's go to number 5. Okay. The amount of coffee dispensed in the cups of an automatic coffee machine has a mean of 5.5 ounces and a standard deviation of 0.3 ounces. What percent of the cups will have between 5.2 and 5.6 ounces of coffee? Okay, this is very specific with the decimals, but because we are being given decimal situations, and also we know that fluid ounces are not discrete. This is going to be measured in a continuous amount, okay? So we can use the numbers as is. Now, if it were a discrete situation, like like I said, specific objects that can't be taken in sections, then this wouldn't work. I mean, we would have to adjust, and which we will do in a few minutes with other questions. But because make note, the situation, you can take, you know, small portions of ounces in a cup, and we do have decimal points, so everything is good. We can do this as is. Okay, so what do we have? So we need to do second bars, number 2. Okay, our low is right here, 5.2. Let's enter. And then here's our upper, that's 5.6. Enter. The mean, right here, 5.5. Enter. Deviation, ooh, very tiny deviation, 0.3. Enter, enter, enter again. We want a percent, so you say times 100, enter. And there we go. 47.19 rounded, and that will work perfectly. All right, now, number 6, the average age of administrative officers at a large company, okay, is 54 years old. So this is our mean. That's what, well, I could write my mu a little better, couldn't I? This is our mu. That's a tiny bit better. It's our mean. With a standard deviation of 5 years, what percent of these administrative officers are younger than 47? Okay, younger than. So we are not including the 47. We want everything below. So that means we're fine. If we're not needing to include the 47, then we can enter the numbers as we see them in the problem and make an adjustment for only having an upper value. Okay, so second bars, number 2, and our lower. That's what we have to adjust. For this, we put in -1, second E. Well, it's second division to get our E. Then 9, enter. Now, what we have here is 47. Okay, enter. Our mu, our mean is 54. And then the standard deviation is the 5 years. And enter, enter, enter again. And I want to make a point that after you enter everything, you see where it gives you all the information. Every time we've done this, and it tells us what we used was the normal CDF, okay? And then it shows everything we put in, right? Okay, so, but it asks us what percent. So times 100, enter, and that will be rounded to 8.08%. So B is the correct option. All right. So let's keep going. We'll move on to the next one. Number 7, on a standardized test, the mean of the scores is 150 and the standard deviation is 10. What percent of all the test takers scored above 144? Okay, we are not talking about the score itself. And we are not talking about, let's say, like the prior problem, the age of a person. Age can be in a non-discrete, continuous time increments. Like money, time, those things can be in a decimal form. In this situation, we're not asking about the score. We're asking about the physical test. That person taking that test. This is discrete. You cannot take it in pieces. That being said, the way the question is worded, it says what percent of all the test takers scored above. So to make sure that you're not taking pieces, that you're taking that whole part you need to add on a, a little fraction, a half. Okay. So what do we need? We need to say that we want above. So this will be our low for 144.5. This is how we get above to the next whole number. Okay. I know it doesn't seem logical at first, but you need to think about it and understand the way your calculator functions. Okay. All right. So let's get this done and see what happens. All right. All right. So we do second bars, number 2. Okay. Our lower is the 144.5. Enter. The upper is going to be that very large number. Okay. Because you want everything above that. So that's 1. And then we need second division, which gives us our E, then 99, okay? Then enter, and our mean is 150, so put in 150, okay? Enter, and our standard deviation was the 10, okay? Let's enter that, enter, enter, enter again. There's a lot of entering. Okay, now we want a percentage, so that's times the 100, enter. And there we go. What rounds for us? Well, looks like option C is what we need. Okay. And let's stop and look at the options. Obviously, A wouldn't work. But if you mess about and you don't do the altering of the test to add on that half, I'm kind of suspicious of what would happen. Okay. What would happen? So I'm going to go up and grab what we had. Remember, I said it displays it. That's what displays. Now I'm going to push enter. I captured it. I brought it down. So I'm going to go over and I'm going to get rid of that half we added on. And let's take a look at what happens. Okay. So I'm going to say delete, delete. Okay. And I'm going to say enter. Ah, that is highly suspicious. Look at what it does. It's going to give us the wrong value. Because what would happen is it wouldn't give us all the values above. Okay, it would actually give us include the 144. So it would include the number, our guide number, our 144. So that would be off. We want everything above, not including 144. So that's a way for me to show you what would happen. Okay. All right. It's just something to keep in mind as you're working. You really have to pay attention to the English. What is really honestly being asked. Okay. Let's move on to number 8. A Consumer Reports study revealed that the mean value of all homes in a certain area in Texas is 175,000. Okay, so this is our mean. Okay. With a standard deviation, okay, of 4,000, what percent of all the homes are priced between the 180,000 and 220,000? Okay, now let's think about this one again. This is not ounces of, it's not fluid, like water. We're not talking about water being drained out. We are talking about the discrete situation, just like tests. This is homes. We don't slice homes up. And we're not asking about, and it says between. So we're not asking about fractions. We have to go from one whole house to the next. There is no situation in between. And if we were to graph it, we would talk about dots on a graph. Now, if we were talking about the money itself, then yes, that's discrete. We're not talking about the money. We're talking about whole houses. That's where the English is different. Okay. All right. So what do? Well, we have to adjust. Well, this one will be plus the 500, and you have to use, uh, depending on what the numbers are. Think about it. How would it work? In order to get it to work in our calculator, we have to, on the upper, we have to say 500 more. Then on the lower, we have to subtract the 500. Okay. Now, the study guide does it a little differently, but the way they do it's fine. You just have to be consistent. If you take off the decimal, I mean, not the decimal, the thousand, the last three zeros, you have to follow through on all of them. Okay. I choose not to do it that way because this is cleaner, in my opinion, for me. Either way, practice it, look at it, and make it make sense for you. Okay. So what do? We say second bars, number two, our lower. Well, that's going to be 179, 500. Remember, we had to slice off $500. Okay. We went below. Okay. Because we have to count the house that was valued at 180,000. Okay. Now our upper, uh, we have to include the house that's 220,000. So we're going to add the 500 on there. Okay. All right. Now take a look at what I did. Think about what I did. If you really give it some heavy thought, you'll see it makes sense. Okay. Now our mean, well, that's okay. We just put in the 175,000 because that doesn't need adjusting. That's not what we adjust. Okay. All right. Now let's push enter. And then the deviation was 40,000. I may have said 4,000 earlier. It's 40,000. Okay. Enter, enter, enter again. And then it's a percent they want, so times 100. Push enter. And there you go. It's option B. Okay. This is the last question for this particular video. I want to thank everyone for watching. And I truly appreciate everyone that has subscribed, shared us, liked us. And I wish you the best and happy testing, everybody.